So now we're moving into two-step equations, all right? So the first one was just one step. We identified, was it adding, subtracting, multiplying, dividing, and then we used the opposite to undo it, right? Now this one here is going to has a bit more steps to it. So there may be more than one variable within the equation, right? One side may actually have more than one variable on the side. So those kinds of questions I think I have on the second page, right? We have some variables, more than one variable. And what we have to do is clean them up first. We have to collect like terms if we happen to have that. After that, then we have to do the order of any adding, subtracting, then division, multiplication. So think about what we're doing. We're going opposite of order of operations to BEDMAS, all right? So order of operations is brackets, exponents, division, multiplication, addition, subtraction, right? So we are moving this direction. So this collecting of like terms is just getting the question kind of organized. You put things together that go together because sometimes the questions aren't always in their simplest form. So we want to get them in their simplest form, and then we go the opposite direction. So we undo any adding and subtracting, and then we do division and multiplication.
So brackets go last.
So brackets, they're going to be kind of somewhat first and somewhat last, all right? So when you're looking at, if you're looking on the very back page when we get to section 4, I'll show you what that is. Kind of brackets, some brackets go first and some brackets go last. So you'll know what I'm talking about when we get, because remember in order of operations, sometimes we have to do things inside of brackets, sometimes we don't, right? Depending on what it is. But today we're just going to worry about, we're going to do these steps right here. I didn't include any exponents, I didn't include any brackets today. So we're going to worry about these. So the fact is that adding and subtracting always gets, because when we think about when we did algebra, adding and subtracting was our last thing, collecting of like terms, getting our final answer. So therefore, that should be our first step if we're going the opposite direction, all right? So this first one here, I'm just going to review what we did last day. But you will notice that there is a little bit difference. Last day, we always had a plus sign there. So we have a positive 7, right? And and then I have subtracting an x, all right? Or you can think of it as a negative. Now, there are hidden ones in these questions, right? There's always a coefficient in front of a variable. So all of these spots over here, all of these have like a hidden 1, okay? And they're important, all right? So when I'm looking at this, I want to do adding and subtracting first. So that means I need to get rid of the 7 first. It's being added to the question, even though the little plus sign isn't on the front. We know it's adding. So I'm going to subtract it off of one side, subtract it off of the other side, just like we did last time. Cross it out. I'm left with this negative 1x equaling a negative 4. Now last day, the x's were always positive. You never did any that had the x to be negative. Well, this is a negative 1 being multiplied to an x. So how do I undo multiplication? Division, right? I divide. So again, dividing is the little line that goes underneath the number. So I'm going to divide both sides by negative 1. So what happened to my answer?
Too early for this.
It went from negative 4 to positive 4. So when I end up with a negative x, if I want to flip it to be a positive x, all I have to do is flip the sign on the other side. All right? I'm going to show you over here. So again, here's my x term. That means I need to get rid of the adding and subtracting because this is the multiplication part. Negative 1's being multiplied to the x. So it means I have to get rid of this guy first. So again, he's added, so I'm going to subtract him off. All right? That's going to do that. And I get a negative 17 equaling this negative x. I'm going to leave it like that because we know it's there. But I want my x to be positive. So if I change it from a negative to a positive, that affects everything else. So what used to be negative 17 becomes positive 17, right? because essentially this is what I'm doing. I'm dividing by a -1. And so it changes my answer.
I don't get it.
Well, let's keep going. I've got lots of examples.
Okay.
All right, so now I'm looking at this question. Do I have any adding and subtracting with my x? No. I have a -1 being multiplied to an x, and I have dividing by 2. All right? Now, with solving equations, we always want to get rid of our denominator first. Okay? So I've got something that's multiplied, and I have something that's being divided. Dividing is the one that you want to get rid of first because it's in the denominator. So how do I undo dividing? Multiply. So I'm going to multiply both sides by 2. That cancels those guys out. Remember, make sure you're doing your bracket. So now I'm left with that -1x equaling a -12. How do I get x by itself? What am I going to do with that -1? Divide. X is equal to +12. Oh, circle my answers. Okay, let's keep going.
No.
So I have a -21 equals to a 1/2 x. Again, I have 1 being multiplied to an x. I have a dividing by 2. What's the first thing I want to get rid of? The 2. It's in the denominator, right? I have no adding and subtracting. So I'm going to times this side by 2, and I'm going to times this side by 2. Make sure we're using our brackets. Cross out, cross out. So I get a -42 when I do the multiplication, and I have a 1x. Does that 1 this time mean anything? No. So up here I divided by the -1. It changed all the signs. Is this 1 actually going to do anything? No. So I can really just go -42 equals x. Because it doesn't really change anything. That 1 doesn't make any difference. But now, in the next one, I changed it to a different number. All right, so I've got a 2/3 x equaling 12. So again, 2 is being multiplied to the x, and I'm dividing by a 3. Which one do I remove first? The 3, right? It's being divided. So I'm going to multiply both sides by
3.
the 3. That's going to eliminate that. Then my next line is going to read 2x is equal to 36. Now, how do I get rid of the 2? Divide. What I do to one side, I do to the other. Cross that one out, and I get 18. Okay. So I've got 14 equals a -7x divided by 2. All right, so I've got a -7 times the x, and I have a divided by 2. Which one do I get rid of first? The 2. So I got to multiply both sides by 2. I get a 28 equaling a -7x. Do you notice that the last thing that you remove is the number that's in front of your x? That's the last thing. It's always going to be your last thing. This last step of dividing by something is always going to be your last step. The only time you don't divide by anything in the last step is when it was a 1. If it's a -1, you still have to divide. So far, so good? All right. So let's move it up to another notch. So I've got a fraction equaling x divided by 16. So I'm looking at the side that has the x on it. So that's my right-hand side. What operation is happening with my x? Division, right? How do I remove that 16? Multiply. So I'm going to multiply it to the numerator. That's going to cancel it there, but I'm just going to multiply it to my numerator there. Now, I don't want to have to get a calculator out, right? And go 16 times 9 and divide by 4.
144.
So, but Do you see something that could cancel before I multiply that together?
Uh,
Yeah, I could take the 4 out of the 16. Do you see that?
no, that doesn't work.
Yeah, it does.
No, it doesn't.
4 goes into 16, so I'm going to cancel that and cancel that, leave with a 4, so I'm going to end up with a 36.
See, I could have did that now.
Okay, so that's your multiplying fractions back in your fraction chapter, right? 9 over 4 times by 16. I guess you could have gone 16 times 9 and then divided by 4, right? But I noticed that there was a 4 and a 16 that was common, so I just reduced them first. Took a 4 out of each, left with a 4, so 4 times 9 gives me 36. Okay, let's try this again. So which side am I looking at first?
The one with the X.
Right. So I've got, what does this mean?
That is negative.
Negative 1, right? There's a
Yeah.
number in front that's negative 1. And then I have a dividing by 10, right? Good. We always eliminate the denominator first. So I'm going to divide by 10. Okay? That side gives me a negative x. Can I clean this up?
Yes.
Yeah, I can.
5 and 10.
5 and the 10 cancel out, leaving with a 2. It's the same thing as if I went negative 30 divided by 5. That's an easy one. Or I could have taken a 5 out of each. And I just have to remember that it's 2 times a negative 3, which gives me a negative 6.
And then divide.
Dividing by what?
1. Negative 1.
Negative 1, right? Because there's a 1 here. Divide by a negative 1, which switches my sign. Okay?
I wrote the question in the wrong box. Thanks, Michael. I really appreciate it.
Okay, boys?
You gave me
We
one.
don't need to talk for the sake of talking. All right, again, this time I've got a negative 4 plus an m, and then everything is divided by 2. So in order for me to get to this guy, now this is the one case where I cannot subtract off, I cannot add this 4 off first because of the whole thing is being divided by 2. So I have to remove this one first in order to get this by itself. Do we see that? That there is a difference between negative 4 plus m over 2 equal to 3. Do we see that there's a difference between these two questions? Yeah. The 2 is only with the m. So I would add the 4 to this side, then multiply by 2. But in this case, I got to get rid of this 2 first here so that I could deal with just the numerator. So I'm going to multiply this side by 2, cancel it out, multiply by 2. So it's going to leave me with a negative 4 plus m equaling 6. And I've got an m there, so I need to get rid of the negative 4. And since it's a negative 4, opposite of that is a positive 4. Adding 4. M is equal to 10. Is there a dividing step in this question?
No.
No, because there's nothing in front of the m except for a plain one.
More questions.
Yeah, this one's a little bit big section because it's a lot of different variants. Okay, we're going to keep going. Okay, so this is the exact same question as the last one, except I flipped it to the other side. Give it a try. Okay, so I have a negative 6 equals a negative 4 plus x divided by 3. Everything is being divided by 3. So I'm going to deal with getting rid of that dividing by 3 first by multiplying both sides by 3. And that's going to give me a negative 18 equaling a negative 4 plus x. How many had that step? Good. Then I had a negative 4, that's adding and subtracting, so I'm going to add to get rid of it, to undo it. What I do to one side, I do to the other. So I'm going to get a negative 14 equaling my x. How many had that one? Good. All right. The next ones, let's go with, I'm going to jump to this guy. b divided by 9 plus 4 equals 3.
What?
This one right here.
I have to
I'm
do
just
that.
going down this
I
one.
have to do that.
Okay, I'm going right here. So b divided by 9 plus 4 is equal to 3. I've got dividing by 9 and I got a plus 3. Which one am I going to eliminate first? Adding, subtracting is first, right? This one I had to get rid of the dividing by 3 because the top was full thing. Right? So also the one thing is, some people think of it as this. This is my B term. I'm going to cover it up with my finger. Anything that's not covered up with my finger has to go first. Because this is my B term. This is eventually what I want to eliminate. I want to get by itself. So that means the positive 4 is the farthest thing away from the B. I got to remove it first. So I'm going to subtract the 4 off. Yep. B divided by 9 is equal to a negative 1. Now, how do I get B by itself? Times it by 9, both sides. Okay? Let's go back to this one. I have a negative 12 equals a negative 15 times A plus an 8. So I got a negative 15 and I have a positive 8. Which one do I remove first? The 8. How do I get rid of it? Subtract it off. I get a negative 20 equaling a negative 15A. So negative 15 is being multiplied to the 8. How do I undo the multiplication? Divide. Now you're probably going, oh, that doesn't work. You can have fraction answers. So 20 doesn't divide evenly by 15. 2 negatives will give me a positive. And what is 20 divided by 15? Common, what's common between them? 5, right? So I get a 4/3. Don't go to a decimal. The only time you're going to go to a decimal is if the question is in decimal form. All right? Leave it in fraction form. Okay? Let's flip to this one. Negative 9 equals 14 plus 7. So now we're going to get into that other step. Is that question simplified as much as we can? So if I look at my left-hand side, I have a negative 9m. There's not much I can do there. But my right-hand side, I've got a 14 plus 7.
21.
Right, I need to put it together. Right, I want to get it down to one number. Because I don't want to subtract off a 14 and then subtract off a 9. Why would I do that? Put them together first. So a negative 9m is equal to 14 plus 7 is 21. Collect your like terms. Then you look at your question and decide what is your next step. Right. The only thing I have left to do is get rid of that negative 9 in front of my m. Kate, stop talking. Excuse me?
Just trying to do my math.
I'm done with the attitude.
I'm trying to do.
Right, so then this is the last step, is to divide by that negative 9. And again, I end up with a fraction form. It's going to be negative because I only have one negative. And 21 and 9 share a common 3. So I can remove a 3 and get a 7/3. Okay, I want you to try these two. And then we're going to move to these biggie guys down here. Give those two a try at the top. You just put your pencil down when you're done so I know I can move on. All right. So did we add 7 to both sides, get a negative 22, divide by 2 and get a negative 11?
Yes.
Perfect. This one, did we catch the subtracting of 6 first?
Yes.
And then dividing by negative 4 and giving me a negative 12. Good. All right. Let's go to, no?
Don't even want, no, don't even want.
You're okay now? All right. Let's go to these guys right here. So I've got a negative 6a minus 3a plus 2a equaling a 10 minus 2 plus 7. Okay? So I cannot get an a by itself unless I have one a, right? All of these equations have had one a or one x, one variable, right? I have 3 of them at the moment. So put them together. Collect your like terms, put things together, get your question down to that smaller form where all you have to do is add and subtract and multiply and divide to get rid of your answer. So 6a minus 3a gives me a 3a, plus a 2a gives me a 5a. There's no changing of signs or anything. It's just collecting like terms. You're not undoing it. You're not getting rid of it. You're just putting it all together. You're just collecting all the pieces back together. And then on the other side, I have a 10 minus 2, which gives me an 8. 8 plus 7 gives me a 15. So when I put everything that could be together back together, all I'm left with is a 5a equals a 15. Now I can use the strategies of undoing what's there. I have a 5a equals 15. That means I got to eliminate the 5, right? And I eliminate it by division because it's the number directly in front of my a. It's being multiplied. Undo it. A equals 3. Not too difficult? All right. Let's look at this one. So this time I've got a 3x, I got a minus 2, I got a plus 5x, and then the other side I've got a 6 minus 8. Does everything on this side go together? No, just the x's, right? So I'm going to do my x's first. I'm going to put them together and get that 8x. I still have that minus 2 that I'm going to deal with after. And on the other side, I get a 6 minus 8 giving me a negative 2. So now that I've got it down to my x term, I have this adding and subtracting term, and I have a number on the other side. Well, I'm going to get rid of this plus 2 because I need to get the 8x by itself. So I'm going to add 2 to the other side. I get an 8x is equal to 0. So when I divide by the 8, 0 divided by anything is still 0.
Isn't something to the exponent of 0, isn't that 1 or something?
Yes, the exponent of 0 is 1. But we're not dealing with the exponents.
How does that work?
I'll explain it later. All right, left-hand side. Can I do anything, clean up the left-hand side before starting? Yeah, I can. I can go 20 minus 6 and get that 14. Then I look at my right-hand side, see if I can clean up anything before I start moving things around. Oh, I've got a bunch of x's. Well, I might as well put them together. This over here, a negative 8 and a negative 6 gives me a negative 14. And then I still have a positive 12, so that's what? A negative 2x? And then I still have that plus 18. I could have put the 18 first and then minus the 2x. It makes really no difference what order I put them in. It's just the fact that I have an 18 and a negative 2x. So now my x's are on the right-hand side. I need to get this guy by itself, this negative 2x by itself. So how do I undo the positive 18? Subtract it off, right? What I do to one side, I do to the other. Are we seeing the pattern?
No.
By now, hopefully you see the pattern. And then my last step every single time is to get rid of the number that's in front of the x by division. So x is equal to a -4 divided by a -2 gives me a +2. Okay. No, this guy here is the same as that one there. So we're good there. And why don't you just take a moment, finish the last two.
Coronavirus.
Okay, when you're done, take a look at it. Did you do the steps? Okay, make sure you're showing each of the steps. That's where you're going. -20. Did you forget that the fact that the p was negative? There was a -1 in front of the p. So when you moved it down here, you still had a -p left. You might have had a +p, right? So that -1. If you are doing that consistently, go in and put your hidden ones in. And then that forces you to divide by that -1 in the end. All right? Can we do this?
No.
Well, glad to hear it.